Hey everyone, welcome back to Electronics Eternity. In today's tutorial, we'll be building a stock picker using an API and market data to help decide whether a stock is a good investment or not. We'll use the ESP32 microcontroller to perform simple calculations like cash flow and the ratio of current asset versus liabilities. While API is allowed for a wide range of market data evaluation, we'll focus on these key metrics which are cash flow and current asset versus liability comparison for simplicity and also to demonstrate the ESP capabilities in performing this task. For this tutorial, we'll be using the API from Financial Dataset AI. So Financial Dataset AI is an excellent resource for both historical and real-time market data. The platform is easy to navigate with interactive guides that makes it accessible for all skill levels. Based on my experience, I give it a 5 star for its user friendliness and reliability. Their customer service is also fantastic, especially in their Discord channel, where you can get your support and advice from Financial Dataset AI. If you're looking for a solid market data API, I highly recommend that you check out Financial Dataset AI. So this tutorial will have two parts where we'll be focusing on cash flow analysis for the first part, just to get the understanding, and then we will move to current asset versus current liability comparison.
So now let's look at the code. So at the beginning part of the code, we have all these libraries included. So we have Wi-Fi, time, HTTP client, and Arduino JSON. So we will be using all of this. Uh, Time is for the time function is for us to get time, as simple as it sounds. HTTP client is basically going to help us establish HTTP connection, and Arduino JSON is going to help us deserialize uh, the JSON string that we will acquire in this project. Right. So next is this is the basic Wi-Fi credentials. Next is the time function variables. So this is the pool.ntp org that we need. So basically, it's an NTP server. Next is it's the GMT offset. So depending on your location, you might need the GMT offset in seconds, right? So 28,800 is the number for my location. So it will vary from a location to one location to another. So you might need to uh, be sure of what is your GMT offset. Some place might not have it, some place might have it. The same applies for daylight offset. So for my location, it's zero. We don't basically have any daylight offset, but it might be different from where you are from, right? So next is integer. We have this year, last year, and the year before last year, so which are placed as last year, right? So the same three variables, we have it in char as well. So I will explain why do we need this in char as we go through the code, right? So next is boolean. We have a boolean, and the initial value of the boolean is false, right? So all this will be needed for the time function. So in short, it will help us to get time related detail, such as what is the time now, what is the year, what is the month, what is the date, and etc. Right? So we will understand more about this as we go through the code. Next is we have char as test. So test will basically carry all the stocks abbreviation. So we have Apple over here. We could probably add, we can add more if we want. For example, we can add NVIDIA as well, right? So it doesn't matter how many. It's just that all this will be placed in this particular pointer, name test, right? So and it will go through every single one stocks that we have over here, and again, so whatever charge that we get from here, we will basically put it in a pointer as well. So I will explain that why we are putting it in a pointer. Again, it's the same thing. We just place it in a pointer so that the function can make use of it later. Next is the declaration of the JSON document. So it's doc. So as per this library, we need to declare this at first, and we have a float named cash flow. So we have like a so we have three. It's an array of three cash flow floats, right? So we'll have three values for this, and that's why I've declared it as three. Okay. So next is, okay, let's look at the void setup. So void setup is basically the usual. It's serial begin, and then it's serial. It's initiating the Wi-Fi connection. If the Wi-Fi connection doesn't work, it will keep trying until it gets the Wi-Fi connection successful, right? So that's it. And next is, once it is successful, it will print serial line as Wi-Fi connected. Next, we will configure the time. So these are the variables that we declared earlier at the beginning of the code, and we would allow some 5 seconds for that configuration to take place. If it's successful, if time success equals to false, it will print local time. So we will look at the local time in a bit. So the local time is another function uh, at the bottom if I'm not wrong. So where is local time? Print local time. Okay, this is void print local time. We will look into it right after this. Okay, so if time false is success, keep on doing this until we get that right. And and next is we have number of tickers. So number of tickers is basically is this one. So we have two tickers. So it will get number of tickers by dividing the total size of the ticker with what is the size of one single ticker. So it's going to give us how many tickers we have. For example, if one ticker is 8 bytes, then if we divide with the total size, let's just say it's 16. I'm just giving an example, right? So let's just say 8 bytes plus 8 byte is 16. So 16 divided by 8 byte. 8 byte represents the size of a single ticker, and therefore it's going to give us 2. So it's going to give us 2 tickers. So the number of tickers will be 2. So, and we take that value and we loop it through a cash flow function. Cash flow function is what we have over here. We will go through that in detail after this as well. Okay, so we have come to the void setup function. We have completed the void setup. The void setup only runs once, right? But if you want it, you can just shift all this and put it in void loop, right? But I don't want it to keep running forever, so I only run it once in void setup, right? But then you can pretty much change it to whichever way you want it. So in void setup, we run print, we get the time, and for each of the tickers that we have, we run the cash flow function. Okay, so that's what is happening in void setup. Now let's look at the void print local time that we discussed earlier. So inside this void print local time, we will have a struct named time info. So what the function does is basically from this particular library that we declared over here, right? So it's a simple library function to use, right? So you don't have to manually create a function to get time. So that makes our job a lot easier, right? So if get local time fails, given that all the variables that we have configured over here, right? So all the variables that we have configured over here, given that it fails, it will serial print fail to obtain time. And while we fail, right, or for as long as we fail to get the local time, it will keep printing out a dot. So it would look like loading is in progress in order to get the local time. Okay, so when we break out from that, that means when we have successfully established the local time, it's going to break out from that while and if loop, and it's going to change the boolean that we declared earlier to true, right? So which then goes back to over here. So it only runs when the value is false. That means we will only get the time function or the time value once. So the moment it is successful, like what we see over here, it will change it to true and it will not run again, right? So by doing that we could ensure that we only run this once, even though we keep it in our void loop, right? So there's an if function over there. So we don't want this to be running multiple times because we only need time once and we take the value that we get from the time and then we process it, right? So let's look at the next one. So this I've commented out these values, right? So I think so serial print time info, or you can just enable this if you want to look at how the whole string works. So I think this is year, hour, minute, and seconds, and these three I forgot what it represents. Year, I think it could be date, month, and etc. Okay, so date, month, etc. So you could just uh, enable this field again just to see how does the entire struct looks like, right? But for me, it's not relevant, and I only need the year. The reason why I only need the year because I'm doing cash flow calculation for every year to see how a company is progressing in terms of its cash flow, right? So we have a chart, time, year, with five values, right? So the reason why we have five is because year is usually four digits, and we want the last to be the null terminating character, and therefore it's five. So we have this string format time. So string format time basically, as you can see, it basically takes the char, right? It takes the char, it takes the size, and then it takes the format, and then it asks for this struct in which we will change the value, right? So the whole function is over here, and that is how it's being used, right? We take the char, we define the size, and we take the format. The format is over here. We want the format to be in just year alone. We don't need anything else. And then this is the struct value, right? So you can go through this, right? And you can get the value. So if you want to know what is the final value, you could always enable this back and you would get 2025, right? So that's how it's going to look like. So now when we get this year, it's basically in char format, and therefore we cannot perform any addition or subtraction to it, and therefore we have to change it to integer. So how do we do that? We do that by using ATOI. So ATOI is basically char to integer. It will change the value to integer. Okay, so how do we get this here, right? So we basically minus one. Okay, so the reason why we minus one and we set as this year is because let's just say now it's 2025 and we want to get cash flow. So we wouldn't know what's the cash flow of 2025 simply because 2025 isn't over yet. So we could only work from 1 year before, which is 2024, right? Which is why I've mentioned that as this year. So in short, we cannot get 2025 cash flow because the year is it's not at the end yet, right? We would only have the cash flow in the financial statement after the end of the year, right? So which is why we have to minus one and we get 2024. And the next one is will give us 2023, and the next one will give us 2022, right? So as you can see, this is the result. I have 2024, 2023, 2022, right? Again, this is what we have declared over here. I hope it makes sense now. And so so now since we have changed that value, now we're going to store it in a char format, right? So we're going to change integer to char, and we will be using this, right? So integer to char. So this is the value, this is the character, this is the, sorry, this here, okay, this is the value of the integer, right? And this is the char, and I think this is the size, right? So I think I've put 10 for the ease of understanding, like just to, I put some random value. I think this could be slightly less than that. You can try out. So because it's dependent on the size, I think you can go up to 5, right? So we could try that as well. So if you really want to know what is the right number for this, I think I put char 10 for the ease of, for sake of simplicity, you could always serial print line, and you could put this here char. right? And you see whether it works or not. For example, you change this to 6 or 5, and you run this line and you see what's the output that you get, right? To me at this point it doesn't matter because I think it works with 10, but I think if you want to like maximize the storage saving, you could reduce this number and see how it works for you. Okay, so that is pretty much it for the time function. So we have gotten all the years in integers, and we also have converted them back to char again. So the reason why we are doing that is because we will take this char values and we will pump into our cash flow function, cash flow void that we have over here. So we will discuss that after this. Now let's look at void cash flow. So void cash flow needs an input as a ticker, right? So as a character, and the character is the ticker, right? We put an open bracket over here because the ticker char size can be random. It can be 3 characters, it can be 4 characters, depending on the name of the company. So we simply print starting void cash flow just to inform us that the cash flow is running. All right. So what do we have over here? So number of years. So we're trying to identify uh, the number of years that we have over here. So we take size of the year. So year is declared over here. As you can see, you have the year, right? So we take these values and we pump it into this so that we could create uh, a for loop, right? So it takes the size of the year and it divides by uh, what is size of uh, one array of year, right? We have multiple arrays over here, divided by 1 it would give us the size. So now why do I do this, right? Let's just say you want cash flow comparison for 4 years or 5 years, right? You can always create another one variable over here. You can say last 2 years or last 3 years. You can create one, and all you have to do is just simply create another one over here and add the particular variable over here, and it will create that for loop for you, and it will run without missing out any of the value. So that's the reason why I've done this, because I only want 3 years comparison. So uh, I only have 3 years over here, right? So you could have more than 3 years. You can have 4 years, you can have 5 years, depending on how critical you want your calculation to be. You can do that, right? So regardless of how many years of comparison that we have, the for loop function will execute the comparison for each and every one of them, right? So next is we are going to uh, establish a HTTP address, right? So this HTTP address, these are the constant values of it, right? So what we are going to do, we're going to take the char and we're gonna append that with the ticker. So the ticker over here is, it can be Apple or Nvidia. So we have Apple or Nvidia over here. So it appends the ticker over here, and then it adds mid one. Mid one is basically middle one, and then it appends this, and then it appends the year, and then this is the value, and then it appends the mid two, so this is the value, and then it appends the footer, the year and the footer. So how, in short, how it would look like, it would look like, let me just put that for the ease of understanding, right? So it would look something like this, right? After it's being appended, so it will take Apple, and then it will take this, right? We just go through with this, and then we'll take mid one. So this is mid one. We'll just copy it over here, and then we'll take year. So let's just say the year is 2024, and then it'll take mid two. So mid two, it will append with this, and then what do we have? We have year one again, right? So we have year one, 2024, and it will append with the footer. As you can see, year one and then footer. So it does this for every year, right? It does this for every year. So this will be the HTTP address that we need to get our cash flow, right? So it basically all that this string concatenate is doing here is basically construct, like, append all this to produce a final string that looks like this, and we can establish a HTTP connection to this particular HTTP address, right? So that's how it looks like. So I'm going to just take that out, right? And what I was saying, right? So this function over here, number of tickets will run for regardless of how many number of tickets you have over here. You could even have another one. Let's just say it's Microsoft or something. You could even run another one, right? So, and it will run for every single ticker. As you can see, number of tickers, it will run a for loop, and this cash flow will run for 3 years based on how the code is being created, right? So we have 3 years of values that we're going to use in this for loop, right? As we declared earlier, we have this year, last year, and last year, right? You can add more depending on your need, okay? And so since we have established the HTTP address, so we're gonna start the HTTP connection. So we declare this variable over here, HTTP client, HTTP begin header, and then we're gonna add a header. So whenever you are trying to establish an API connection, at times you will need API key, right? So this is just some random API key. You can check out the website name Financial Dataset AI. You can always get your own API key and you put it over here. For free features, you don't actually need API key, but when you expand, you start to use more and more, you would need your API key, right? So if you have like extensive number of tickers you want to use, you might need the API key, and you can key in that API key over here to make sure that your HTTP query is successful. So next we get the HTTP code. If the HTTP code is greater than 0, which often denotes success when we try to establish the HTTP connection, so it basically process the value. So string payload is HTTP equal get the string. We are going to remove all this. Payload remove 2, payload cache flow statement, payload remove 3. So the reason why we are doing all this is because we want to we want to make the JSON string uh, comprehensible for this JSON function. So we have a JSON function over here, right? And it needs to be in a certain format, right? If I'm not wrong, the format has to be in this particular format, right? It has to be like this. Let's just say ticker, and then it has to be AAPL, and then it has to be something like this, cash flow, and it has to be certain digits, right? It has to be in this format. That's only how we could deserialize the JSON successfully, and that is what I am trying to do over here, right? If you want to understand step by step what I'm doing, you could always remove the comments from these lines, and you could see how it looks like at first and how it looks like after we perform all this removal and replacing to see what's the final payload looks like, right? So the final payload that we have created will be we will take this, right, and we will add one because we want the string to have some extra terminating characters. So we add one, and then we say the JSON string length payload to char array JSON string length. All right, so we want to convert it to char, and we always need to add one to accommodate the final null terminating character. Okay, so we plus one, we create a char named JSON, and we pass the value to from payload to JSON with this length, right? That's how it works. And once we have done that, we check if there's a deserialization error, because if there's a deserialization error, then we're not going to get any of these values, because simply because the function failed to comprehend the meaning of the JSON string, right? So then we're not going to get nothing. So that's why we need this. If there is error, it will throw out an error. That means you should need to look out for something, right? And next, if the error is not there, then we start pulling like meaningful information out of it. So we would take char stock, the stock name is ticker, and then what is the cash flow. So cash flow is cash flow for the year is 2024. So we'll put that in this first one. So the next time we go up here, and when the for loop starts to become 1 or 2 or 3, then it will store in this particular cash flow again. So as you can see, the return gives us three different values. It's 2024, 2023, 2022, simply because we have 3 years. So every time this for loop runs from from 0 to 1 and 2, then it would store the cash flow values in different arrays of cash flow. So that is what is happening over here, because we don't want the values to overlap, and we place it, and we misinterpret this information. So you see 2024, 2023, 2022. So serial print ticker equals the stock, and serial print year. So what year is this? And then we print cash flow, and then we divide that by 1,000, simply because the value is too high, right, for float. So I think it gives in 9 digits or more. So that is why we are dividing that by 1,000, so that we get a decent number that looks like this. Okay. So we go back to the if statement again. So this is from this if statement. If statement HTTP code is greater than 0, then do all these things. But if it's not, then you print there's an error on HTTP request. Then we terminate the HTTP connection, and we allow some delay, just for the systems to run, or maybe even relax a bit, right? But I think this, you can try this out, you can take this out, see if it's necessary. I just want to allow some delay for the systems to run smoothly. So next is what we do is we take the cash flow and we compare with the previous years. So cash flow 0 will be 2024, cash flow 1 will be 2023. This one 2023, 2022. So in any ways, if we are seeing an increase in cash flow, we're basically saying cash flow is good. But we see continuously deteriorating cash flow. That means 2024 is lesser than 2023, 2023 is lesser than 2022, then we say cash flow is bad, because in none of these years we see the cash flow is growing in comparison to the previous years, and therefore we say the cash flow is bad, right? So that's how we do a cash flow comparison with this. Okay, so if we look at the result, so this is the result that I have gotten earlier. So you could see Wi-Fi connected, starting white cash flow, ticker is equal Apple, and we could see this is for 2024, this is for 2023, this is for 2022, right? So we have taken the value of cash flow from the API, and the API is very useful, that is giving us this value. We can take it, we can do some meaningful calculations, and voila, we have we have a cash flow comparison with the past years. And regardless of how many tickers that you put, it will run for each and every one of you, each and every one of them, to make things a lot simpler, right? So with that, we have come to the end of the video. I hope you enjoyed this session and learned something new. Until we meet again on the second part of this ESP API 32 video, right? Until then, we meet again. Take care. Bye bye.